leave a trail. Network protocol always leave a trail. So mamaya makikita niyo yan pag nag-sample ako ng isang activity for Wireshark. So it always leave a trail. May trail talaga siya. Then whenever you find a strong trail, you join them. So it's a way na kung saan yung communication protocol na yon mas maganda yung transfer niya, dun kayo dadaan. And once you find a trail, it will lead you back to your starting point. So when we say once you find a trail, it will be leading from source to destination, and the destination becomes the source going back to the destination. So may trail. Back and forth, the information must have a trail that it can lead back to the source and the source to the destination. Okay. When we say governance of computer network protocol, it defines the interaction sequence between entities and the corresponding action must be in order to achieve a networking goal. So nakita natin na dapat siya yung sequence of interaction between entities must be in order. Hindi pwedeng nauna tong part na to before this part. So that means to have a networking goal, dapat chronological yung events. The goal is routing the message end-to-end from source device to a destination device. So ito yung sinasabi ko sa inyo na it will leave a trail from your source to your destination, and your destination will be the new source and going to the destination. So the message must be delivered and the message will be answered. Ganun yung mangyayari lagi. It will route the message. So a network protocol is a defined set of rules and messages structures that communicate entities in a computer network must follow. So it must follow. Yung network protocol na yon na binigay sa'yo for that particular message must be followed. So yun yung network protocol. Okay, protocol layering. So protocol layering is the diversity stem from the need of including end devices are. So because of there are so many models and capacities, different example or different implementation of protocol layering is being implemented. As well there are many vendors who are developing their own protocols. Okay. For example, Cisco has its own proprietary protocol for link aggregation. Okay, they have their own protocol for that. Other vendor for Cisco for networking equipment have their own protocol for different functionalities of their network switches. So those are different protocols that must be identified or accepted by the protocol, by the layers. So when we say layers, ito yung pagkasunod-sunod na sinusundan ng information. So ito nga yung dinidiscuss natin ngayon for the network protocol. So there are also many operating system and middlewares. So for a router, there is a different version for its network operating system. For Cisco, it's iOS XE. So meron din si Dell, meron din si HP, and then si Aruba. So different manufacturers of these networking or servers have implemented different protocol. So the diversity for that is so wide na kailangan we have a set of standards and rules, and in order to communicate the information from a source to a destination. Okay, network and link technologies, yun nga, marami tayong vendor for networks, marami tayong vendor for end routers and core networks. And usage requirements. Depending on the usage, it can be a small network to the core network or a sub-network. Okay. So given that, protocol layer refers to a group of related functions that are performed in a given level in a hierarchy. So while protocol layering divides complex network protocols to simple network protocols. So yung layer, it's a group of function. While protocol layering, it divides that network protocol into a simple network protocol, SNP. So that the process can be expedited. Okay. Network protocol stack. So the protocol stack is a set of layered horizontal protocol. Horizontal siya ha. So each layer uses the service of the layer below. So the information will be transferred from the layer below, then transferred to the next, then transferred to the next, and transferred to the next. So there are two common types of protocol stack. One is the Internet Protocol Stack or the TCP/IP model. And the other one is the Open Standard Interconnection Stack or the OSI reference model. I don't know kung na ano niyo na siya, na-discuss yun na on your previous classes or yung mga previous subjects nyo. So there are two widely used. But for standards that are being adopted ngayon, TCP/IP model. For the OSI, it's something of a reference model for developers, for APIs. Okay, so Internet Protocol Stack or the TCP/IP model consists of 5 layers. So when we say 5 layers, this is layer 5, layer 4, layer 3, layer 2, layer 1. Ayan. Okay. So each layer consists of a protocol stack. So for layer 1, it's called the physical layer. When we say physical layer, it consists of the physical connection for the protocol stack. Then for the link layer, this is the communication between the physical layer and the what they call this, the conversion of the physical information to logical information. Then the network layer, ito na yung mga TCP/IP, UDP, 443. Dito may mga ports natin. Then sa transport layer, ito yung nagde-define kung ano siya, UDP ba siya or TCP. And the application layer consists of your application, yung Google Chrome, Facebook, Twitter, Instagram. Okay. Okay. This is the further explanation. For the physical layer, the physical layer is the transceiver that divides the signal into the network. So bits 1 and 0. So ang tinatransmit na data ng physical layer is 1 and 0. 1 and 0. Then going through the data link layer, the data link is responsible for creating the frames that move across the network. So, for the creating the frames, it consists of the physical MAC address. So, mamaya meron din yan. Then, once the physical MAC address is transferred to the next layer, the network layer is responsible for creating the packets. So, yung IP address mo, 192. Wait lang po Then once na convert na yung IP address nyo, for example, ito nga yung 192.168.0.0, it will be now transported to the transport layer. The transport layer establishes the connection between application and different hosts. So, siya yung nag-establish ng connection from the remote host. After that, it will be transferred to the application. So the application is a group of application that required network communication. So, for example, dito kayo nag-search nung sa Facebook. Dito yan. Facebook. Okay. So, ito yung example natin. So, from the physical layer, ito yung nakakonect natin sa network. Ito yung RJ45 natin. So, from the application, sabi ng application layer nyo, for example, a web page, I want to download a web page from this address. So, the address is 192.168.1.102. Okay? So, the application layer transports out information to the transport layer, in which it determines if the required information will be a TCP or a UDP. Then, it divides the information 192.168.1.10 into a source and destination port. When we say source port, what will be the source port of the application connecting to the destination port? So, when we say it's 192.168.1.10, the destination port will be port 80. So that will be connected to the first message. So sinama natin siya dun sa I want to download. So the information will be segmented or added to the first message. Then when we the information or the message is carried through the network layer, yan. So, another information will be included. The source IP address and the destination IP address. We know that the destination IP address is 192.168.1.102. And your source IP address will be your networking device. Kung ano yung IP ng ano mo, kung anong IP ng computer mo. So for example, it's 101. So the information source IP address and destination address will be added to the message again, together with the source port and destination port and the message. Then it will be, call this, it will be, the message will be transported to the data link layer. The data link layer will append your source MAC address and destination MAC address. So when we say source MAC address, it will be the MAC address of your physical device, of your wireless network or your local area network. And the destination address will be the MAC address of your destination port. So you have source MAC address, destination MAC address, source IP address, destination IP address, the source port, and the destination port, including the message. So this will be the frame. So from the message, we created a segment. From the segment, we created the packet. From the packet, we created the frame. Once the stack is complete, it will be transmitted to your physical layer. Ito na yung RJ45 na nakakonect sa inyong computer. Or kung naka-wireless kayo, ito yung wireless connection nyo dun sa inyong router. Okay? So don't forget that the message, the application layer, transmit it to the transport layer and produces a segment. From the transport layer, it transmitted it to the network layer and produces a packet. From the transport network layer, it goes to the data link layer and it produces a frame. So in the transport layer, the append information will be source port and destination port. So port. While on the network layer, it must be the IP address. Don't forget, this will be included in your examination. So source IP address and destination IP address. While on the data link layer, it will be the MAC address. So para hindi niyo makalimutan, port, IP, MAC. So the network layer produces the packet. The data link layer produces the frame. Okay, so basically for easy understanding, your physical layer, parang siya yung delivery truck na magdi-deliver sa'yo ng, for example, a package. While the data link layer is the crossroads or yung mga roads na kailangan niyang puntahan para makapag-deliver sa'yo. While the network determines point A to point B, yung route na kailangan niyang daanan para makarating sa inyong bahay. Then the transport layer will be your door na kailangan ma-deliver dun sa bahay mo, kakatok dun sa door. And the application is your package, kung anong laman yung package. So for easy understanding the physical layer is your delivery truck. Siya yung magdadala. The data link layer will be the crossroads. O yung mga dapat yung daanan. Then the network is the identification of point A to point B. Ano ba yung route na kailangan kong daanan? Then the transport will be yung bahay, yung door. And the application will be your package itself. Okay? Ayan. This is an example of how we can capture. Example ako. So I will be using an application called Wireshark. Nakapag-install na tayo niyan, di ba? Kita naman po. Kita po.
Yes po.
Okay.
Kita po, sir. Yes po, sir.
So, ito yung in-install natin na Wireshark, di ba? So, ang ika-capture ko is yung Wi-Fi ko kasi nakakonect lang ako sa Wi-Fi. Okay. Capture na siya. Stop ko na. Ano tayo? Facebook. Gmail na lang.
Yung statement of account may valid.
So, nagka-capture na yung aking packet tracer. Papansin nyo maraming information na dumadating. So, let's stop. Okay. Then, I will search for an HTTP traffic kung meron tayong nakuha. So, wala. So, SSL traffic tayo. Okay. So, we have an SSL traffic, yung ating Wikipedia. So, na-capture natin siya. Okay. Yan. So, dito sa na-capture nating frame sa Wireshark, kita natin na from my destination, ito yung aking router. Yan. Yung Huawei. To my source, Intel, kasi naka-Wi-Fi ako. So, pumunta ako dun sa aking router. Ito yung ating layer 4. Kasi yung 5 natin is yung ating application. Then we see the source. Ito yung aking IP address. And to the destination. Ito yung destination ng ating pinuntahan na web page. Okay, our protocol is TCP. Yan. So, our protocol is TCP. So, it's also defined dito yung source. Ayan, yung 22. And the destination, yung 103, 102, 166.24. Under our transmission control protocol, we have the source port 50998 and the destination port is 443 kasi SSL. So nakita natin na yan, SSL siya, 443. Then if we go to the transport layer security, so ang sabi niya, naka-TLS version 1.2 ako. So, ang aking version ng aking transport layer security is TLS version 1.2. HTTP over TLS. Later sa laboratory nyo, meron din tayong ganito. So, yan. Wireshark application or a network capturing tool can capture the 5 layers of the TCP/IP model. Okay. Let's continue without saving and close this one. So let's continue. So another network protocol and protocol layers is the Open System Interconnection or the OSI reference model. Okay, the OSI reference model is developed by the ISO or the International Organization for Standard. It provides a generally accepted conceptual reference. So yun nga conceptual reference model or framework for of a layered protocol of the model na lang siya. Widely na kasi ngayon na ginagamit yung TCP/IP model, in which the TCP/IP model governs how the internet works. Okay, there are principles of OSI. So one, create a layer when a different abstraction is needed. For this one, it created layers when needed. If we compare it to the TCP/IP model, the layer must be sequential, in order. May procedures and rules. While the principles of the OSI is it creates a layer when a different abstraction is needed. Okay? It implements in each layer a well-defined service. So, there is some difference on the number of layers on the OSI model compared to the TCP/IP model. So, it also minimizes information flows across interfaces and chooses services of a layer. So, nag-choose siya ng services dun sa layer, hindi siya sequential talaga. Okay? So, this is the OSI reference model. So, the OSI reference model is divided into two parts. The communication and the application. In which, under the application, there are two layers, application layer and presentation layer. While under communication, we have the session, the transport, the network, the data link, and the physical layer. So under the application layer, these are the network process to the application. So this some of the example of the protocols within the application layer. Ito yung mga web natin. Basta ito yung mga applications na running on the web. On the presentation layer, it is the data representation and encryption. For example, ito yung mga XML, HTTP, XML, JSONs, Java. So those are presentation layers. On the part of the session layer, it's the inter-host communication. So, inter-host pa lang. So, nasa host pa lang talaga yung communication. Hindi pa lumalabas sa internet. So, when it goes to the transport layer, it is the end-to-end connection between the source and the destination. So, usually, it uses the TCP or UDP protocols. While the network layer determines the paths and logical addressing. Ito yung IPv4, IPv6. Ito na yung IP address na kailangan ng ating network. While the data link layer defines the physical addressing and frame control. Ito na yung MAC address. Dito na siya. And the physical layer, this is the media transmission. So ito na yung ating Ethernet cables or wireless connection. So basically, the OSI reference model is divided into two, the application part and the communication part. So this is an example on how the process for OSI. So when the sending from the application protocol, it attach the application protocol, then transmit to the receiving process. Then the presentation protocol attach the presentation protocol together with the application protocol and the data. On the session, it attached the session protocol to the presentation protocol and application protocol going through the session, and so on and so forth. So every time the information is transmitted to a new layer of the OSI reference model, it appends the protocol concerning those concerning the sending and receiving process. Okay. So if we compare the OSI reference model between the TCP/IP model na 5 layers and the TCP/IP model na 4 layers, so don't be kayo malito dun sa 5 layers and 4 layers. Actually, the improvement on the TCP/IP model that it joined the data link and the physical layer. Kasi ang sabi naman kasi nila dati na the data link and the physical layer is one equipment. Kung ito yung networking card natin, na in which the MAC address is actually burned in dun sa ating network card na yon. Kaya nung dinefine ulit yung TCP/IP model na 4-layer, naging link layer na lang siya. So okay, if we compare the OSI together with the TCP/IP model, so the application and presentation and session layer is actually done by the application itself. Kasi kung matatandaan niyo yung session layer is host-to-host pa lang. So yung inyong application, for example, your Google, your web page, it actually queried the, kunyari, facebook.com. Ang kinwiri niyo pa lang naman is yung host nyo. Yung computer nyo pa rin naman. So, it was defined that the session layer is actually combining in relation again dun sa application layer. Hindi naman siya different. Also with the presentation layer. Kasi yung presentation is on Java, in which those protocol runs within the application. And the application layer itself. Ito yung application mismo. So, on the TCP/IP model, it was pinagsama na yung application, presentation, and session layer. So, mas lumiit siya. Mas naging, hindi siya naging mas komplikado. Transport layer, it's the same. It's the same transport layer. For the network layer, it was defined the internet layer. Kasi ito na yung ating IPv4, IPv6. So this protocol connects us to the internet. Okay? Then the link layer. The link layer sa OSI reference model, it's data link and physical layer. So, yun nga. The physical layer and the data link, actually, nasa isang equipment lang siya. Yung networking card nyo lang. So, it was later revised na it will be named the link layer na lang. So, the link layer is now function as the MAC address and the connection, the physical connection to the internet. Okay. On the performance for the network protocol, we have network delay, packet loss, and throughput. So when we say network delay, it is the time difference from the transmission instance of the first bit of packet from the source until the reception of the last bit by the destination. While packet loss occurs when a packet arrives up to a pool queue at a router. So when we say occurs when a packet arrives to a pool queue, remember that communication, especially for information, must be in a queue. So hihintayin niya yung buong buong message mo before it can be transmitted. And throughput, the rate, bit per second at which the bits are pumped into the network by the sender side to reach the destination. So, what is network delay or network latency? So, yun nga yung sabi natin kanina, di ba? It's the time difference from the transmission instance. So, we can actually test that using online speed test and command prompt using ping and trace route. So, for example, okay, for my end, I was able to ping google.com using 32 bit of data, 32 bytes of data, with a total time. So my packet send is 4, my receive is 4, so I have zero loss. So my transmission to google.com is without loss. Then I have a minimum round trip of 19 milliseconds, maximum of 53. So my average turnaround time for my google.com ping is 28 milliseconds. So if I'm going to use trace route to a server, for example, this website, so going through my router, it's 2 to 3 milliseconds. Going through my public IP address, then to converge. Okay. So my total turnaround time for this trace route from my computer to this server is around 200 milliseconds. So if we calculate the okay, kita niyo po, around 200 kasi siya yung highest. So if we look at this one, my average is 198 milliseconds. So same result. So we have seen na using the command trace route and the command ping give us a almost the same result na alos 200 milliseconds round time para ma-access natin yung server na yon. Okay. Online speed test. So, so if we're going to use speed.cloudflare.com, so it's a free online speed test. Ayan. Ayan. Okay. Medyo cache and cheater. Okay, let's wait for the testing to be completed. For this one, so, medyo mabagal ang aking internet ngayon kasi nagkaka-problema sa Converge. So for my download, it's 13.1. For my upload, it's 18.9. So my ping from Philippines to Singapore, it's around 79.1 milliseconds, so medyo mabagal. And my jitter is 79 milliseconds. So jitter defines your network latency. So mayroong what do you call this? Time delay between when the signal is transmitted and when the signal is received. So meron akong time delay. So that's 79 milliseconds. So it's quite high kasi dapat hindi ganyan kataas yung jitter. Pag ganyan yung jitter mo is ibig sabihin medyo may problema yung internet mo o mabagal yung internet mo. Or yung iyong bandwidth is fully consumed. So, okay. Yan. So that's from Philippines, may location to Singapore. Okay? So mataas yung jitter ko. Tingnan natin kung magre-reset. Taas pa rin. Yan, at least bumabay na yung jitter. Naging 11.5 na. So that's good. Okay? Okay, packet loss. So packet loss is a network performance test in which you can actually see kung ilang packet yung nalolos mo during the transmission of your information from the source to the destination. So, kung gagawin ulit natin yung ping test, yung ating trace route, pating na lang. From a unit, okay. So I have packet loss here. Okay. Let's see. Let's wait for the command to finish. Then next is throughput. So throughput, if we compare it to network latency versus throughput versus bandwidth, your throughput is the measurement of data transmitted and received during a specific time period. So para siyang yung tubo sa inyong sa pipe. Kung gaano karaming tubig yung na-transmit niya sa pipe na yon. So yung bandwidth is the measurement of the capacity. Kung gaano capacity yung kayang kayanin ng inyong pipe. Then the latency is the destination. Gaano kahaba yung pipe nyo. So, if we compare it doon sa nabibiling yung mga connection, for example, is 500 Mbps connection. So, the bandwidth is 500 Mbps. So the throughput is on how much information or data that 500 Mbps can transmit on a specific length. So yun yung latency nyo. So throughput is it measures the data, the capacity of the data transmitted during a specific time period. So kung i-ano natin siya kay speed test, ay kay ping, kung ipipin natin nga itong si website, okay, for a 32-byte information going through my internet connection, the throughput going through the server and back to me is 172 milliseconds. Ito yung throughput mo. Specific time period. Yeah, specific time period. For a 32-byte information, sabi niya, di ba? Measurement data transmitted. For a 32-byte information, the total run throughput from the source, my computer, through to the destination, this website, it's 172 milliseconds. So that's your throughput. You can also use the Tamasoft software, pero sa next na natin siya gagamitin. Kasi magde-deploy pa yan eh. Okay? Ito na tapos yung pathing. Okay, this is the pathing. Okay? So using the pathing, we can determine the source, loss sent, and the percentage. So when I use the pathing to connect to this server, every router up to the 7th router, zero loss ako. Ayan. Okay? But going through the 8th router, wala na. Kaya naputol na yung trace ko. Okay? So loss and send, I have zero loss until the 7th hop or the 7th router. But going to the 8th, nawala na. Pa natin siya pag kay Google na walang putol. Okay. Maganda yung makukomplete. Yan. So, na-complete. Ganda yung nag-complete eh. That's sweet. Okay, let's wait. Okay, that's the last slide. So, do you have any question? Hintayin lang natin ma-complete itong isa. 150 seconds. That's... Um, 4 minutes. Sige, pakita ko na. So, do you have any more question before we end our session for today? Hello, class?
Wala naman po, sir.
Sumawag ka na. Ibalik mo
Wala
yan.
po naman, sir.
Okay, so pakita ko na lang ito mamaya sa ating laboratory part. Medyo matagal na eh. So, I will be seeing you around 6 p.m. for our laboratory. So, if you don't have any more questions, so thank you for attending our lecture and see you on our laboratory. Thank you.
Thank you po, sir.
Thank you, sir.
Thank you, sir. Thank you po, sir.
Thank you po. Thank you, sir.